Welcome to this CUBE conversation. I'm Lisa Martin. Bren Briggs joins me next, the Director of DevOps and Cybersecurity at Hypergiant. Bren, welcome to the CUBE.
Hey there, glad to be here.
You have a very cool background, which I wish we had time to get into your mandolin playing, but we don't. Tell me a little bit about Hypergiant. This is a company that's new to me.
So we are an AI and machine learning company, and we had the slogan we talk about a lot. It's almost tongue-in-cheek, tomorrowing today, where we want to build and focus on technology that advances the state of the art, and we want we have this deep history and background in services where we build custom solutions for companies that have data problems and that have AI and machine learning problems, and they come to us and we help them make sense of their data, and we build a custom software solution from top to bottom, and we help them with their data problems and their really difficult problems that they have there in a very specialized way. And yeah, that's what we do. It's really fun.
Tomorrowing today. I like that. Need t-shirts with that on that. So talk to me about the work that you guys are doing with SUSE, Rancher Government Labs. You're doing some very cool work with the Air Force. Help me understand that.
Sure. So about a year and some change ago, we had a government contract, an Air Force contract, to develop just some new, or to basically run an experiment with some new sensing technology on board a satellite. So we built this satellite. We were talking about how we're going to employ DevOps best practices on the satellite, and if that's even a thing that can be done, how we get these rides to space, and really thinking through the entire process. And as we did this, we were getting more and more deeply involved with a very, very new group. Actually, we kind of started at the same time, a new group within the Air Force called Platform One. Platform One's mission is to bring DevSecOps to the DoD enterprise. And so as we're kind of starting off together and getting to know each other, Rob Slaughter, who started and ran Platform One for the first bit of its existence, he said, hey, we're going to incorporate some Platform One stuff into this. Let's talk about just building an actual Platform One satellite and see what that looks like. And so that was kind of the start of this whole idea, was what do we do and how do we do DevSecOps in low Earth orbit? Can we put Kubernetes on a satellite and will it work?
And you tell me some of the results. So I used to work for NASA, so I geek out on anything that has to do with the space program. But talk to me about some of the things that you uncovered bringing Kubernetes, AI, machine learning to the outer edge of Earth.
I think the first thing that we learned, and I think it's an understatement to say that space is hard. But it really is. And that was the part that we learned about, was it was hard in all of the ways that we did not expect. And a lot of it had to do with just government and logistics. We learned that it is difficult a lot of times to find a way to get into space. And then once you're there, how you operate and the conditions that you're in, and how you can even communicate with your satellite it's just a logistical adventure on top of all of the other engineering problems that you have while you're on low Earth orbit. The other thing that we figured out was software updates are difficult while you're on orbit. They can be slow or fragmented, and so it pays to get it right the first time. But that's not the nature of modern software development, is you never get it right and you're continually updating. So that was a problem that really nagged us for a while, was after we did the WIDAR experiment, how would we continuously update this and what would we do? And those ideas and questions fed into the experiment that became SAT-1, and then the follow-on, much bigger experiment that became the EDGE-1 and EDGE Working Group.
Tell me a little bit about the WIDAR experiment. Give me some context of how that relates to Platform One, SAT-1.
I can't really go into details about what WIDAR did or anything like that. It was not a classified mission. It's just not something that I can disclose right now.
Okay, got it.
Sorry.
So talk to me about some of the work that you guys are doing together, Hypergiant, with SUSE, in terms of pushing forward the next generation of Kubernetes to low Earth orbit and beyond.
Sure. So SUSE RGS, specifically Chris Newber, one of the things that I have to do is I have to be a cheerleader for all of the amazing people that were on this project. And two people in particular, Chris Tackey and Chris Newber, were instrumental in making this work. I was like almost tangentially involved, where I was doing some input and architecture and helping debug, but it was really Chris Tackey and Chris Newber that made this thing, that built this thing and made it work. And Chris Newber was our assigned resource from SUSE RGS. And he said, obviously, SUSE is going to prefer SUSE products. That it makes sense. But there's a reason. It's because the products that he implemented and the patterns that he implemented and the architecture and expertise that he brought were second to none. I don't think that we could have done better with any other distribution of Kubernetes. He recommended K3S as a very lightweight Kubernetes distribution that had really good opinions. It was a single binary. It was very easy to deploy and manage and update. And it didn't break. That was the best thing that we were looking for, was that it was one solid piece with no moving parts, relatively speaking. And so, Chris Newber was very essential in providing the Kubernetes architecture, while Chris Tackey was the one who helped us write some of the demo applications and build the failover and out-of-band interaction that we were going to have from the hardware on the satellite to the Kubernetes control plane.
Very cool. It sounds like you had a great collaborative team there, which is essential in any environment. And I liked how you described space as a logistical adventure. That reminds me very much of my days at NASA. It definitely is a logistical adventure, to put it mildly. Talk to me a little bit about the work that you're doing to define the edge for the Department of Defense. That sounds very intriguing.
Yeah, so this was almost a direct result of what happened with the Sat-1 experiment, where Rob Slaughter and a few of the other folks who saw what we did with Sat-1, were again, logistical adventure. We built this entire thing and we worked so hard, and we're moving through flight readiness checks, and as things happen, funding kind of went. And so you've got all this experience and this like prototype that's really confident that it's space ready and everything. And they said, hey, listen, we have the same problem on Earth, like with terrestrial environments. They're nearly identical. The only difference is, you don't have to worry about radiation nearly as much. And so then, we joked about that, and we started this new idea, this Edge 1 idea, as part of the ABMS program, where they're figuring out this new like battlefield communications pattern of the future. And one of the things that they're really concerned about is secure processing, and how do you do applications at like where people are stationed, which could be anywhere in very remote locations. And that's what turned into Edge 1 is we imagined initially Edge 1 as satellite 1 without wings and earthbound. And that grew into, well, what about submarines? What about carriers? What about command and control squadrons that are stationed in cities? What about special operators that are far forward? What about first responders who are moving into hazardous environmental conditions? Can you wear a Kubernetes cluster with like super low power ARM chips? And so we started thinking about all these different applications of what Edge could be, anywhere from a 5-volt board all the way up to a data center in a box. And that caused us to realize that we're going to break Edge into really 3 categories based on the amount of material or resources needed to power it and how hard it is to get to. So we have the near edge, which is, you have data center-like capabilities, and it's easy to get to it, but because you have people stationed with it, but you may have reach back once every month or so. So think, a ship that's underway, or an air gap system or something like that. And then you have a tiny edge, which is like kind of the more traditional idea that you think of when you think of edge, which is really, really tiny compute. Maybe it's on a windmill or something. I don't really know. Pick your thing to put Kubernetes on that should never have Kubernetes. That's the tiny edge. And then you've got far edge, which is, if the control plane crashes, good luck, you're never getting to it. And so that would be a satellite. And so so really a lot of these, it depends on the failure mode, like what happens when it fails, and that for the most part defines kind of what category you're going to be in.
Tiny edge, near edge, and far edge. I think Sir
And
Richard
far edge.
Branson and his team went to the far edge of low
They
Earth
did.
orbit this last weekend. I guess, yeah, that low Earth orbit does seem like it would be the far edge. Talk to me a little bit about, I mean, you talk about these the applications, and from a defense perspective, that vary dramatically. What are some of the important lessons that you've learned, besides if it breaks in the far edge, you're not getting to it?
Some of the important lessons that we learned. So I actually did this exact job in the Air Force. I was a combat communicator, which meant that we took, by pure coincidence, I'm back in this. Like I did not intend for this to happen. It was pure coincidence. But you know, we communicate. We went out to the edge, right? We went out to the near edge, and we did all of this stuff. And the biggest lesson, I think, learning from doing this and going into, or doing that and then going into this, is that the world doesn't have to revolve around SharePoint anymore, because we can ship our own applications.
That is good to know.
If it can be done on SharePoint, the Air Force and the Army will do it in SharePoint. I promise you. They've done some actually terrifying things with it. All joking aside, though, I think that one of the things that we learned was the difference between like something being complex and complicated when it came to systems engineering and management. Like this is a very complex system, and it's actually orders of magnitude more complex than the current deployments that are out there, which is effectively VMware, and you're migrating virtual machines across multiple physical nodes in these remote data centers. But it's also complicated. It's really difficult to manage these deployments and the hardware. And I remember like when I was in Combat Comm, we had this 72-hour goal to get all of our systems up. And it was kind of like a 50-50 if we would make it, it felt like most of the time, where you had priorities for getting things up and running. And obviously, you know, certain applications weren't as important as others. So they were the ones that had to fall on the wayside if you're going to make your 72-hour mark. But I'm just thinking about like how difficult it was to deploy and manage all of this stuff. And now with Kubernetes, yes, the complexity is far higher, but we can make it so it's not as complicated. We can offload a lot of that brain sweat to people in the rear echelon, where they can connect in remotely. After you come up and you get reach back, they push your config and your mission profile is there. And now you're focused on the mission. You're not focused on debugging pods. And you're focused on the mission and not focused on, you know, why my virtual machine didn't migrate or something like that. And we can get applications that are built in-house and updated continuously, and we can verify and validate the sources of where these things are coming from. And all of these are important problems to everybody, not just the military, but the military tends to have the money and the ability to think about these things first. And so that's where these problems tend to get solved first. So
interesting, you sort of had this circular experience being in the Air Force, now coming back and working on projects like this. What are some of the things that Hypergiant has learned, and some of the things that are next for Hypergiant as a company?
I think that we are getting really good at being a small contractor in the federal space, where we actually were just awarded an IDIQ with a cap of $950 million in a small group of, I think, 23 other companies. And so that shows right there the investment that the federal government has in us and the potential that they see for us to build and deliver these highly tailored and specialized solutions. The other thing that we've learned is how to form like coalitions to collaborate with a lot of these other smaller companies. I think that the days of seeing the defense industrial base dominated by the same 4 people or 5 people are over. And it's not that these people, I mean, they've basically been propping up most of the defense industry for a very long time. And I think a lot of people would argue that, you know, this is a problem, right? You have this near monopoly of a very few people. But the other thing is that they're not as nimble. They can't, you know, they grow by acquisition. And we have this ability to be highly tailored and specialized, and we don't need to do everything in the world to survive. We can go and form coalitions with other groups to go solve a particular problem. Like, we're great at AI and ML, and we're great at DevSecOps, but maybe we're not so great at hardware or, things like that. Like we can go partner up with these people and solve problems together, and we don't have to be Boeing to do it. And you don't have to go hire Boeing to do this. And I think that's really, really great. No slight to Boeing, but I think it's really great that it's a lot easier for smaller companies to do this. And we are navigating this new world, and we're bringing Agile into the government. And that's, in some cases we have to drag them kicking and screaming into this decade, but that's what we're doing. And I'm very excited to see that, because when I was in Agile and DevOps, those were words you didn't say. You weren't allowed to do that.
No.
And now they've done a complete 180. It's really cool.
That's cool. At a minimum, it brings in thought diversity, having more companies to work with. But to your point, the agility that you bring in as a smaller company, helping them to actually embrace Agile, that's huge, because to your point, that's kind of historically not what government organizations are used to. So it sounds like, and I'll bet, they've learned a tremendous amount from working with small companies like Hypergiant.
I like to think so. Platform One is a fantastic example. So it was really started as what we're calling software factories within the Air Force and within the DoD, and other DoD branches have now started to replicate the pattern. So we have several software factories within the Air Force, and Platform One is like the DevSecOps software factory, and we have ski camp and space camping, Kobayashi Maru, and you're noticing a theme here. and so they're very nerdy names. But so we have these software factories, and there's all these projects that are being worked. But one of the amazing things I noticed when I showed up to work on the first day was that I had no idea who was uniformed and who was civilian. It was a completely badge off, rank off situation. Very few people showed up in uniform, and the ones that did typically had their blouse off, so you had no idea what their rank was. Everybody went by first name, and we behaved like a startup. And these civilians were coming from other startups like Hypergiant or Otimo or other very small, very specialized groups. And SUSE RGS, of course, they were there too, and they're embedded in several different teams. And so you have this quasi company that startup really that got formed, and the culture is very, very Bay Area startup type. In some ways, for both better and worse. We're definitely full tilt on on the Agile train there, but it's like nothing I've ever seen inside the DoD, and they're not just learning from these small companies and from Agile companies, but they're behaving like them, and it's spreading. They're seeing what work is getting done and what can be accomplished, and how you can continuously deliver value instead of working for 6 or 8 months and then showing the customer something and then hating it and you sending it back, and it's more of a continuous improvement type thing. And I think that they're embracing that, and very excited to see it.
That's important, because changing a culture is incredibly hard, but seeing and hearing that they're embracing that is exciting. And I'm sure there's going to be many more things you could talk about down there. But I got to ask you, if somebody like SUSE gave you $250,000 and you could buy one of the tickets on Branson's next flight, would you do it?
Yeah. Why would I not? Like, how can I pass up a trip to, go to the edge of space?
The far edge.
The far edge. Maybe I'll just, hurtle a satellite out the window as, we're up there at, peak. And I don't think I can throw it quite that fast, but we'll see. But yeah, no, I think I would take the trip. Yeah, that'd be fun.
You're brave, braver than I am. I don't know. Well, Bren, it's been delightful talking to you. Thank you for sharing what you guys at Hypergiant and SUSE have been doing together, the Department of Defense, the exciting things going on there, and for the new definitions and my lexicon of the edge. It's been great talking to you.
Thank you. Have a great day.
You too. For Bren Briggs, I'm Lisa Martin. You're watching a CUBE Conversation.